Hello, my name is Morgan Nelson. Today I would like to talk about spectroscopy and the problem-solving process. Spectroscopy is the study of absorption and emission of light and other radiation by matter. It will split light into consistent wavelengths into the spectrum, which is how a prism splits light into a rainbow. This process of analysis can also be used with molecules in the organic chemistry setting. The molecular formula that we will be looking at today is C6H12O2, also known as ethyl butynate, which is of the ester functional group. We have 6 carbons, 12 hydrogens, and 2 oxygens included in this formula. So I'll be flipping the camera to show you some tables and charts as we go. The IR table, flip the camera here. So our IR table is here, and this is just going to go over the infrared spectroscopy. This is a list of peaks and frequencies for molecular bonds and functional groups. So as you can see, we have an alkane, an ester, and just CO stretch. And here's the chart that correlates with that. So our alkane group is showing around 2950 to 2850, and you can see that falls on kind of this peak over here near 3000. And then our C double bond O ester group is about 1750, which is going to be this peak in this area here. And then lastly, for this table, we have our CO stretch, which is going to correlate around 1190, so in these wavelengths around that area. Moving on to our next table, which goes over carbons, the 13C table is going to show us where the carbon atoms fall in the spectra depending on how they are bonded. So I will scroll down to the next table. So we have the CO bond, which is the ester group. We can see that spike over here. And then you can just kind of see as each bonding group falls, they each fall with spikes on the table. So OCH2 is around 62, moving over, kind of following down. You can see how the chemical shifts correlate to the table. And then moving down into the hydrogen table. And so the 1H table will show where your hydrogens are observed, including whether they are shielded or unshielded in their multiplicity. Multiplicity simply means the appearance of groups, symmetric peaks representing one hydrogen in the NMR spectroscopy. So we have all of our hydrogens, all 12 represented here, and then they correlate on the following table. The most right-sided are shielded and the most left-sided are unshielded. When they are unshielded, it's because they are attached to a more electronegative atom. The more shielded ones are called shielded because they are getting a pull from a more polar electron. Here is the proposed structure for C6H12O2, the Lewis structure design, and we would call this ethyl butynate. And then I also have built this as my 3D molecule here. So you can see we have the black represent the 6 carbons. So we have 1, 2, 3, 4, 5, 6. The white represent the hydrogens. So we have 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, so all 12 hydrogens. And then the blue are representing our 2 oxygens in the structure. And then thank you guys for watching the video over the combined spectral problem analysis of C6H12O2. This is just a very brief summary and overview. Please do your own extensive research if you guys are interested in finding out more or any other information. All right, thank you.